Okay guys, so in the last video we talked about the lens laws, and this time we're actually going to look at solving actual lengths and distances. We're going to look at the precise measurements. We're going to be able to predict them with mathematics and then see if they actually match up with our diagram rules, okay? So let's see. I'm going to go ahead and just draw out a little diagram for this. I know that's a really terrible drawing. That's okay. Okay, I'm just going to make the center of the lens right there. And let's see if we can actually make this work. Okay, lens has a focal length of 39.1, so I'm just going to go ahead and put that here. 39.1, I'm going to try to make it about the same on the other side. So this is how I would draw this to kind of predict, right? The object is 56.2 centimeters from the lens. So notice if this is our focal length, where is our object at? Is it inside the focal point or outside the focal point? Well, it's outside quite a bit, right? So I'm going to go, it's almost maybe a little under double, right? So I'm just going to go ahead and put it here just for practice. And let's see, so what would our first rule be? From the tippy top, parallel, and then once it hits the center, it tries to go straight for the focal point, right? Okay, the second one is going to go, what's the second rule? It does the opposite thing, right? So it's going to make a mad dash for the focal point on this side, and when it hits the center of the lens, it's going to go parallel, it does the opposite, right? And where these two things meet up, what did we say happens? The image forms, right? So go ahead and make your image straight from the principal axis. It makes sense. Messy. Okay. That's the nice thing about this. I can just extend it on my own however I want. Right? Okay, so start from the principal axis. Draw straight down. And so what we end up getting. So I'm predicting that this is going to be pretty far away. It might be around the same size. Who knows, right? We'll be able to figure that out with magnification. Um, but it's going to definitely be inverted, right? And since it's on the opposite side, we're going to get a real image. Okay, so let's see what happens here. Let's go ahead and do the mathematics. A converging lens has a focal length of 39.1, and so this is our equation. If I do, I die, right? If I do, I die. And there's another way to write this. You can write this as the focal length inverse equals the distance of the object inverse plus the distance of the image inverse, right? Just make sure when you're done with this, you invert your answer, and that's the invert button calculator, okay? So I'm going to go ahead and do this one just to make it a little bit quicker. All right, the object is at 56.2 centimeters, so if that's the object distance, that's going to be DO. This was the focal length of 39.1, so that's our focal length, right? What is the image distance? So this is DI equals question mark. That's what we're looking for, right? What's next? DI is question mark. So make sure to do this, write these things out, draw this picture, label with the numbers. That way you can have some good notes to be able to work on this stuff. Okay? All right, so let's see. My equation is, I'm looking for this guy right here, right? So how would I get rid of this stuff? Well, this is a plus DO, so I would need a minus DO, right? So I'm just going to go ahead and grab this. It's already ready. Okay. So let's subtract DO inverse from both sides. Now I'm going to have, how do I write this? Inverse of the focal point minus the inverse of the distance to object should equal the inverse of my distance to the image. So whatever I get when I put this in the calculator, I need to make sure to invert, right? So I go ahead and plug my values in. What goes into focal point? 39.1. That's the inverse of that. Go ahead and just put it like this. Minus the distance of my object, which is 56.2. Inverse that is my distance to the image. Inverse, right? So I go ahead and put that in the calculator. I invert that answer. I end up getting the top right here, 128.504 centimeters. Okay, so that's how you would do that. It would be pretty far away, right? And that's what we said was consistent over here. But how do I know if it was actually right side up or upside down? So that's when the magnification equation comes into play. Okay, so here's our magnification. It's hi ho equals Dido, hi ho, Dido. It's like the Seven Dwarfs song, right? So this is basically just a proportion, right? The height of my image over the height of my object should be proportional to the distance of my image divided by the distance of my object, right? So this is kind of like looking at the length versus the height, right? We're just doing a really simple proportion, and you put the negative sign in there just to keep things consistent. All right, so let's see. Let's go ahead and do that right now. What was the height of my object originally? Let's say it was, I wasn't given one in this one, so let's go ahead and measure it. Let's say the height of my object was, we got a ruler here. All right, now, so I can actually rotate this guy. There we go. So from 7 to 8.5, that's 1.5 centimeters, right? That's 1.5 centimeters. Okay, 1.5 centimeters. All right, let's break that out. 1.5 centimeters over, oh, that's the height of the object. That's on the wrong part, right? Okay. The height of the object is what we have. We're missing the height of the image, right? So how do I get rid of this if I'm doing proportion? If I'm dividing by HO, how do I get rid of divide by HO? I would need to multiply by HO, right? Height of the object. Okay, so let's go ahead and multiply. And then we end up with pi equals dou over dou. Okay, so what was the distance of my image? That was given to us in the problem. Distance of the image was right here, 128.504. I'm just going to do that for simplicity. Times the height of my object, which we said was 1.5 centimeters. And we end up over distance of the object, and the distance of the object was 56.2. And let's see what that comes out to. This might be a disaster, but I'm at least showing you how to set this up. 128.85 times 1.5 divided by 56.2. So we end up with, and what did I forget to do? I forgot to put a negative symbol over here, didn't I? Okay, so just make sure there's a negative sign. So I ended up getting, and I put this in the calculator, negative 3.429 centimeters. Let's see if we got anything that was even relatively consistent with that. It probably won't be because guess what? I did not draw this to scale. If you actually drew this to scale, it would probably work. Right? So let's see what I get here. I got about 1.5, which is not consistent with this value. And it's because, again, I didn't draw this to scale. This was just kind of a rough sketch. But look what it does give you. This tells you the negative sign means it has a negative height, which means it's going the opposite way, which tells you it's inverted, right? And remember, a converging lens, if it has an inverted thing, you know that the image is real, okay? So that's the mathematics for lenses.